Assalamu alaikum students. Today we are going to see P block elements. You would have studied in your lower class about P block elements, the elements that belong to group 13 to 18 are called P block elements. Let's see. Listen. See, these are the elements placed in the periodic table, and they are called P block elements. That is S and P together called main group elements or representative elements. You would have already seen. Here, the 13 group elements, say boron, aluminum, gallium, indium, thallium, niobium. 13 group elements are called icosahedrons. And group 14 carbon family elements, otherwise called as tetragens. See, icosahedrons, why they are called icosahedrons? Because these 13 group elements, even otherwise called as trials, here icosahedrons, that is icosahedrons, it is because they have 20-phased tetrahedral, 20-phased polyhedron structure, and hence they are most of the metal borides have that structure, and hence they are called icosahedrons, and otherwise called the trials, because the 13 group elements in the main group elements it belongs to third main group element, and hence triel otherwise called as. And the 14 group elements are called tetragens, as they have 4 valence electrons, or the group 4 elements. And the 15th group elements are called pnictogens. Pnictogens, Nietzschean means what to say? Due to the choking property. Nitrogen has the choking property. Nietzschean means to choke. Air contains both oxygen and nitrogen. Nitrogen has more composition in air, that we know that. And 16 group elements are called chalcogens. Chalcogens are called ore forming elements. Chalco, that means ore. Gens means produces. And 17 group elements are called halogens. Halo are called salt gens producers, and we know very well 18 group elements, the most stablest elements, and they are called noble gases or inert gases. See, P block elements are important because they contain all the 3 types of elements, that is metals, non-metals, and semi-metals. Semi-metals, the boron, silicon, germanium, arsenic, then antimony, tellurium. These are said to be what? Semi-metals. Those which are in the lower part, they are metals. Those which are in the upper part, they are non-metals. And these elements are radioactive elements. These elements are radioactive elements. That is niobium, flerovium, moscovium, livermorium, tennessine, oganesson. Other elements we know that boron, aluminum, gallium, indium, thallium. In 14th group, carbon, silicon, germanium, tin, antimony, tin, lead. 15th group, nitrogen, phosphorus, arsenic, antimony, bismuth. And 16th group, oxygen, sulfur, selenium, tellurium, polonium. 17th group, fluorine, chlorine, bromine, iodine, astatine. And 18th group, helium, neon, argon, krypton, xenon, radon. Here, see, these elements are important. That is, we know very well about carbon. Carbon is the backbone of organic compounds, organic chemistry, and aluminum has a wide application, even in household utensils, to manufacture household utensils, and even cables, antennas. Most importantly, it is its ore is used for the manufacture of body of aircraft. They have the general electronic configuration NS2, NP1, 2, NS2, NP6. Boron family elements have the electronic configuration NS2, NP1. Carbon NS2, NP2. Nitrogen NP3. Like that it goes. The 18th group elements have the stateless to completely filled octet configuration. Next to see is the periodic properties. See, if you see the ionization enthalpy, the p block elements of the ionization enthalpy of p block elements, for that is, as we move from left to right, the ionization energy increases. This is due to the electrons, outer electrons are added in the same shape. And whereas as we go down the group, the ionization energy decreases. This is due to the electrons are added in the new electronic shell, and also there is an increase of atomic radius. Next is about electronegativity. Electronegativity in the case of p block elements, the first two elements of each group, there is a decrease, and in gallium there is a marginal increase. That is the third element in all the group. There is a marginal increase, and then there is no variation. And next is the anomalous properties of the p block elements. In the p block elements, in each group, the first member has an exceptional behavior. For example, if we take group 13, boron is a small element due to the small size. Generally, all the first elements do not have d orbitals, and they have small size, high electronegativity, and a high ionization energy. These properties make the first element of each group differ from other elements. And in the case of group 13, boron is a semi-metal, that is metal alloy. It has a diamond relationship with silicon. That is, it is due to the oxides of boron and silicon have a similar acidic character. Even their hydrides, the boron hydrides and silicon hydrides, are easily hybridized. And in group 14, carbon is a non-metal, whereas silicon, germanium are semi-metals, and the other are metals. Carbon has the greater tendency to form chain of bonds with itself or with other elements. That is catenation. And even carbon has highest catenation property. From carbon to other elements down the group, it decreases catenation property. And 15th group elements, nitrogen is a diatomic gas, and even it forms multiple bonds, whereas other elements do not form multiple bonds. And if we take oxygen, there is 16th group elements. Oxygen is also a diatomic gas, and other elements are solids. Oxygen has a high electronegativity. Due to it, it has a tendency to form hydrogen bonds. And in the 17th group, fluorine is most electronegative element. It can have only -1 oxygen state, whereas other elements can have -1 even +1 oxygen state. And let's see about inert pair effect. The tendency of being less availability of NS electron in bonding is known as inert pair effect. Here the post-transition elements like lead, bismuth and all do not involve in bonding. They remain unionized. That is the inert pair effect. It means they are reluctant to form bonds. Inert pair effect increases down the route. And next is allotropism. Most important topic of this is allotropism. Allotropism means the exhibition of different structure of the elements. And in this lesson we have the allotropism of carbon particularly. Carbon has various allotropes such as diamond, graphite, graphene, fullerene, carbon nanotubes. Even boron has amorphous boron, rhombohedral, alpha rhombohedral, beta rhombohedral, gamma orthorhombic, and even sulfur has rhombus sulfur, monoclinic sulfur, etc.